7b97z43f, line 22. Photons, atomic dance, swap, spin, entangle, Fibonacci formula, 5G Wow Seti. This is video F, so you want to start with video A. Every one of them has a formula in them, okay? There's the alien radio signal, and this one's bigger than it should be, because I can't fit it on my camera. Maybe I'll move it over just a smidge. There. Now you fit in there. Okay. So this is a keyword research about atomic dance and quantum qubits, laser beams, rubidium atoms for a UFO space communication ship found in the WOW data line 22 formulas beginning B to F from A. Previous video was video E. There's our quantum dance with our atoms. And September 5th, my thoughts. It was filmed in this video because of its length and depth. The formula is going to continue from previous video. I don't know why I did this, but I did B and D there. Formula from data continues. Crucial to a computer, a logic operation equals an if-then statement, such as if two qubits, Euclid's fifth postulate applies here, contained in ions, have opposite states, anti-symmetric particle properties, question mark, then they should exchange values. Opposites attract plus creating a magnetic force. How do you transfer electrons within a magnetic force of semiconductors? The keyword ID is to Google from formulas in the previous video. Magnetic forces with electrons traveling through them. Quote, a PDF results on the blog. So I Googled those ideas to see what came up, and I found one of your test results, okay? So, 2010, magnetic forces and localized resonances in electron transfer through quantum rings. Okay, there's the name of our scientists. They are from Poland. Abstract. We study the current flow through semiconductor quantum rings. In high magnetic fields, the current is usually injected into the arm of the ring preferred by classical magnetic forces. However, for narrow magnetic field intervals that appear periodically on the magnetic field scale, the current is injected into the other arm of the ring. We indicate that the appearance of the anomalous non-classical current circulation results from Fano interference involving localized resonant states. The identification of the Fano interference is based on the comparison of the solution of the scattering problem with the results of the stabilization method. The latter employs the bound state type calculations and allows us to extract both the energy of metastable states localized within the ring and the width of resonances by analysis of the energy spectrum of a finite size system as a function of its length. The Fano resonances involving states of anomalous current circulation become extremely narrow on both the magnetic field and energy scales. This is consistent with the orientation of the Lorentz force that tends to keep the electron within the ring and thus increases the lifetime of the electron localization within the ring. Absence of periodic Fano resonance and electron transfer probability through a quantum ring containing elastic scatter is also explained. And you want to take a look at their files because they have a lot more to say than what I've put here. So it's www.ncbi.nlm.nih.gov, and that's their link. The formula from the data, September 5th. Semiconductor quantum rings, high magnetic fields, Higgs boson electric field, current injected arm of ring preferred by classical magnetic forces. Net force plus narrow pencil laser beams. Hold on. Net force, we have to add Newton's second law of motion. Those two go together. And narrow pencil laser beams. No. Electron ribbon. Oops. Pencil laser beams. Magnetic field, Higgs boson electric field. Intervals appear periodically. Magnetic field scale. Current injected into other arm of the ring. Indicate appearances of anomalous non-classical current circulation results from Fano interference involving localized resonant states. Identification equals the Fano interference plus base comparison solution scattering problem with results of stabilization method. Latter employs bound state type calculations, allows us to extract both energy of metastable states localized within the ring, the width of resonance by analysis of energy spectrum, finite size system as a function of its length. Phonal resonances plus involving states of anomalous current circulation become extremely narrow on both magnetic field. Higgs electric currents, energy scales. Consistent with orientation of Lorentz force, keep electron within ring increases lifetime of electron localization within the ring. Absence of a periodic phonal resonance in electron transfer probability through quantum ring containing elastic scatter is explained. The keyword rubidium atoms is going to be in the next video, and there's like tons of videos about the atoms, cold properties, how they transfer frequencies. It just goes on and on. So thank you for watching.